Hello, everyone. Welcome to the AI Deep Learning Workshop. My name is Amy, and I'll be hosting it. So I just want to start with a quick intro of who I am, so you can put a face to, face and, info to the voice that's speaking to you. My name's Amy. I'm currently a developer intern at Element AI. It's an AI startup based in Montreal. Currently, I'm studying comp sci at Queen's University. And a fun fact, I'm also training for a half marathon. So as I go through this workshop, feel free if you have any questions just to message hashtag workshop, the workshop channel. And yeah, with that, we can get started. All right, so I thought it would be nice to start with a bigger picture of how machine learning works, how AI works, and just what the bigger picture of this whole process and this whole workshop is going to look like. So here is a diagram of a machine learning pipeline. And now I'll jump into the definitions of AI, machine learning, and deep learning in a few seconds. But for now, let's just look at this diagram and kind of ignore this title. I got this from Google Images. Should have cropped this out, but this is a diagram. So how the pipeline works is that we have a lot of data. That's where we get our information from. And once we have that data, we can't just use it off the bat unless the data is really good. And if you hear people talking about, having good data, having bad data, this is what they mean. Before you train your model or before you can do anything with the knowledge and information you have to manipulate the data in some sort of way. So you have to make it kind of do what you want the data to look a certain way so that when you train it, your functions work properly. And after that, you want to extract features. Now, what does that mean? Feature extraction is when you pick out the parts of the data that you want it to look at, or you want your model to look at. And you can see these arrows here. Can you see my mouse? Okay. Yeah, thanks. So right here, there's an arrow, and you can see how it keeps going back to feature extraction. Whoops. And how that works, it's kind of like a cycle. So you extract the features you want, then you create your model. After you create it, you want to train it on some of your data. And once you've trained it, you want to test it on data so that it you're able to kind of use the knowledge you gain from the model training on other sets of images or text, whatever your initial data was. And then you want to have predictions. Now, if the predictions aren't good, you see this arrow going back to feature extraction and model training and model creation and testing. So it's a continual process of just tweaking everything and making everything better. So that's what all those arrows mean. But in like simple terms, we get the data, we prepare it in some kind of way, then we select what we want the model to look for, we create the model, we train the model, we test the model, and then we make predictions. Does anyone have any questions right now before I move on? Okay, cool. So let's move on and talk about what deep learning AI and machine learning really are. So let's define it. What's the difference? Does someone know the difference here? Okay, cool. So AI is kind of the overarching theme, right? So you hear this thrown around a lot, and what does that actually mean, right? But let's break this down first. We have artificial intelligence. Now we know intelligence is a real thing. Humans have it, and what they mean here, what we mean here by intelligence is that we're able to interpret things. We have human behavior. If I see a water bottle, I know that it's a water bottle, right? And not just a cylinder shape. But artificial, now we add that in. Artificial intelligence here, now we're talking about how do we create that, like artificially? If it's not a human, how do we put it in a machine? So, artificial intelligence is a technique that lets machines mimic human behavior. Now, if we move down a level, we get to machine learning. So, machine learning is a subset of artificial intelligence, and it's a technique. It achieves artificial intelligence by training algorithms to get results by using a lot of data. And now there are a lot of techniques to do that. That's pretty broad. So there are a lot of techniques to achieve that goal. Like there are a lot of techniques to train algorithms to make predictions using a ton of data. Now, one of those techniques is called deep learning. Deep learning is a type, it's a technique that is inspired by the structure of the brain. So, whoops, let's go back up. So it's inspired by the structure of the brain. Now, does anyone have any questions right now before I move on to the details? Okay. If no, I'll just move ahead, and I just want to differentiate between the differences between machine learning and deep learning. It's kind of blurred right now. And let's just talk about some of the techniques and then how do those techniques link or connect to deep learning. Wait, what other things are there in machine learning other than deep learning? Yeah. So I'll just like throw a few examples off the top of my head. There's a ton. So there's reinforcement learning, there's deep learning, there's um, there's supervised, unsupervised learning. And actually, I'm going to talk about uh, the details of supervised and unsupervised because you'll need that knowledge to understand neural nets. Cool. So good question, and very good segue to what I'm about to say now. Thanks. So this is supervised learning and unsupervised learning. So what does supervised mean, right? Do you remember elementary school when you had recess and you would go outside, you would be supervised by teachers, right? And they would tell you what not to do. Don't climb too high, don't go out of bounds, don't go behind the trees. Well, now supervised learning is kind of like that. There are a set of instructions. So you would have data, and here the example is that we have uh, images of fruits, and these are images of apples. And now you're going to tell the model, look at these images. These images are apples. Don't forget that. These are apples. So now you have those instructions and then you train the model. So now when you make a prediction, you can kind of easily infer that the prediction will be that when you see an image that kind of looks like this, it has a green leaf. It's shaped kind of almost like a circle. It's red. It's an apple. Great. So now unsupervised learning. What's the difference there? You would notice here in this image that there are no annotations that tell you that these are apples. Oh my gosh. Okay. So if you have the same images of a ton of fruit, so you can see here we have apples, bananas, peaches, I think. And you don't tell the model, these are bananas, these are apple, these are peaches. What do? Actually, you don't tell it anything. And the model will just infer, or not infer, but the model will be able to look at the images itself and learn that these are apples, these are bananas, and these are peaches without you telling it what it is. So here's a more concrete example, actually. Here's a more concrete example. Whoop. Sorry about this. I'm trying to show you this. So, what's this letter? It's A, right? We can tell it's an A, but how does a machine know that it's an A, right? Because these are all shaped very awkwardly. Like this even has like these swishes, strike throughs, and it has weird coloring. And that it's also a different shape from this, which is kind of written like a backward 6. And then you have, the circular kind of A. How does a machine do that? Well, I said earlier that it's inspired by the structure of the brain. Let's talk a little more about the structure of the brain. So the brain has a lot of neurons in it, and how you know things, how when you see a water bottle, you know it's a water bottle is, well, you have a bunch of neurons in your brain. Neurons just, simply put, they're kind of like they're created of cells, but they also have a lot of connections to other neurons called synapses, and that's how your knowledge is stored. It's stored in the connections between each of the neurons. So deep learning was inspired by this. And let's talk about it more then. And if we go to this, it's inspired by the neurons, and the entire thing, the entire network structure is called a neural net. So this is just a diagram of what a neural net looks like, So what we would call these circles, we would call them neurons as, like the term from the brain. But this is the neural net now. This is not the brain. This is the machine learning neural net. You can see here that it says input and features. Now, from all our examples before, then you would put the input would be your images of your apples, your bananas, and your peaches. And let's skip this for now. The output, the predictions, is what it predicts it as. Like this is an apple, this is a banana, this is a peach. Now, what is here? Yeah, these are called hidden layers. And these layers are kind of they're analogous to the synapses in the brain. And what the hidden layers means is that this is where all the predictions, kind of like the inference, the pattern recognition of the model, this is where it happens. And that's how it creates the predictions. So let's talk about it a little bit more. First, the data is fed into this layer. We know that. And these channels, I'm not going to go too deep into the math right now because, that takes a lot of time to understand as well. And it's really complicated. So if you're interested in the math, I have a lot of resources at the end where you can look into it. But I'm not going to go into the math right now. I'm just going to talk about the overall concept. So each of these channels would have a number attached to it, and it would have a weight. And then all neurons also have a number, and they have, those numbers are called biases. So now how the math works is that the bias is added to the weighted sums of the inputs that reach a neuron. So let's say we look at this top neuron right here in the first hidden layer. You can see that, there's one arrow pointing to it, there's another arrow pointing to it. Look, there's another arrow pointing to it, and there's another one. So there are 4. All of these 4 channels would have a weighted number attached to it. And, this neuron, remember, it also has a bias number. So now this math formula happens, and that function is called the activation function. The activation function has a threshold that if you pass the threshold, then this neuron gets activated. Let's say this second neuron doesn't pass the threshold. Well, it doesn't get activated. And if we say, let's say every other neuron in this first hidden layer gets activated, but the other ones are not, then those 3 every other neurons would move on to the next phase because they have a number. Because they were able to pass the activation function threshold. And it repeats until you get to the second last layer, and basically one neuron is going to get activated from there. And now we're at the output. That one neuron that's activated is the prediction. So let's say, for a more concrete example, let's say this output neuron, or let's say this one, this one is an orange, and this one's an apple. If this one passes the activation function threshold, this doesn't, and at the second last one, only one of them will, then our prediction now is an apple. So that was complicated, but that's the overview of how neural nets work without diving too much into the math. And I just want to add that the weights and biases are adjusted every time the layer, like you move on to the next layer to train the model accurately. Okay, so that's deep learning, and it's great. It's been really cutting edge in the recent years. Turing prizes have been given to the people who invented deep learning, and there are a lot of applications in the real world with it. But it also has some limits. So what are these limits? Because we talked earlier about how deep learning is closer to unsupervised learning than it is supervised learning, because humans don't say this is an apple, this is a banana, this is a peach. Because there's no human intervention like that in deep learning, it's difficult, it's more error prone. And let's say you have a peach and an apple that look you have a peach and a nectarine, right? They look very, very similar. Even me, myself, as a human, I can't tell the difference a lot of the times, right? Now, if you give that to a machine, let's say the model says that this nectarine is actually a peach, right? Now, I can't intervene and say, no, this is not a peach, this is a nectarine. So it's more error prone that way. And this image on the right is an image of a GPU that you need a lot of computational power to train neural nets because of the massive amounts of data needed to train an accurate, a good model. Because again, we go back to the point that we can't just label data. We can't just say this is an apple, this is a banana, this is a peach. Because of that, we would need a lot more data so that there are more patterns that can be recognized by the model so that it gives us accurate predictions. Yeah, so now I think that's enough for theoretical portion. Let's make our own. So I prepared a Google Colab of just the entire process of training a model and getting it to run. And the whole thing would take forever to type. So I actually took out code of a few of the important parts, like creating a neural net, training the data, and testing the data. And I thought we could code that together. I'm going to send the link into the, I'm going to send the link into the channel. Let me just copy this. And feel free to code along. Don't worry, like you can type along with it. And the way Google Colab works is that if you can type stuff, but it won't show up on mine. So yeah, feel free to type anything you want. You can comment some like info, knowledge if you like, and then you can save it as a copy to your own drive so you can have it for reference later. So with that, I don't think you can full screen this. It says you need access. Oh, okay. Is that all it says? That you need access, that you need to request access? Okay. So I guess you would have to, I could accept all of your requests unless there's a faster way. But there are only like kind of like 10 of you, so sure, I'll accept all your requests. Actually, I feel like there's a faster way. Yeah, I turned on link sharing. One second, I think I changed the settings on link sharing. Now try this one. Whoa, I got a lot of requests. Does this one work? Okay, cool. Yeah, awesome. That's good. So we can walk. So it's almost 4 right now. And this ends at 5. Okay, so the parts that we are going to code together is going to be here. We're going to write our own neural net. That's going to be like 20 lines of code maybe. And then we'll train it another 20, and then we'll test it. And I'll walk through the code with you guys as we go. Feel free to ask any questions. Now, I just want to throw in here that I'm using PyTorch as a deep learning library to help with the work. There are other popular libraries that people use, like I don't know why my brain is blank right now. I can't remember the other ones. TensorFlow and PyTorch are the popular ones. Just at Element AI, we use PyTorch. So that's why I did this one in PyTorch. I went through this tutorial when I onboarded. Cool. So with that, let's get started. So here we're just importing the libraries. And actually, you know what would be really helpful? I'm going to bring us back to this. So, this is where we're at right now. We're at after we import it, we're going to prepare the data. So let's exit this. And we'll keep this here. So here we're just preparing the data. Transforms is just from here. You can see that we imported it from PyTorch. It's a function that normalizes the images we have. Now the data that we're using here, it's actually part of the data in PyTorch that they use for examples. So I thought that would be the easiest way for you guys to get the data on your computer so that we could train it together. So CFAR10 is a popular generic data set that's from PyTorch. So here we're just saving it into root data. Now after we normalize it, we are separating the data into a training set and a testing set. Now, why do we do that? We do that because if we train it on the whole thing and we test it on the whole thing, well, that's kind of biased, right? That's like saying this is who's your favorite brother, right? If you only have one brother. So we split it into a training set and a testing set. Normally this is like 60-40, 70-30, kind of like that, where the testing is smaller because, again, we do want a lot of the data to be trained on, especially since we're using deep learning. We would have to we would need more knowledge so our model is more accurate. So that's just this. Now here, this is not really part of the model, but it is so you guys can see what the data looks like. So this is showing the image, and I just will show like a few of the images. You can press run, the button here, and then it should run. Oh, actually, you have to, let me stop this. You're supposed to run, okay, that's okay. You're supposed to run them in order, so my bad. I was getting too excited. So we import it. That's good. All right. And now we're going to run this. This says it's downloading the data. And it's actually pretty quick, actually. So now we're just extracting it. Waiting for this to get to 100, but maybe that might not be necessary. Actually, we do need to wait for it to get to 100. So is it working for everyone right now? If it's not working, feel free to just message the channel and then we can figure it out together. 99. What if I clicked run again? Okay. Nice. So now this is just showing you what the images look like. So you can see this is a cat, this is a plane, this is another cat, and this is apparently a deer. Right now, yay! We're at the part where we're gonna write some code together. So I can make my screen a little bit bigger that you guys can see. It's easier to follow along. All right, so now I see someone's typing, so I'll wait for you to finish your question. Okay. Actually, I'm just gonna, okay, it says it's a read-only notebook. Okay. Maybe yeah, create a copy. Yeah, you create a copy and then you can edit whatever it is in there, and those changes won't appear on mine. They're gonna be solely on your account and your machine. So yeah, thanks. Let's start coding then. So first we want to import the neural net function. So from PyTorch. So import torch.nn. That stands for neural net. And let's just do as nn so that we don't have to type torch.nn all the time. Oh my gosh. My bad. Oh. As nn. And we also want to import another library from the neural net, or not another library, another module from the neural net module. So torch.nn.functional, and let's call it f. And I see that there's a spelling error here. So that's functional. And now we're going to create our class. So class, let's call it net. And we want to pass in nn.module, the neural net module. And now we're going to create the constructor. So init self. And we want to inherit from the PyTorch's neural net module itself. So in Python, that's super net self dot init with the brackets. And then we're just going to create the layers now. So self1 and then dot con 2D. And here we're just we're going to be inputting numbers for like the size of our neural net and everything. So these are kind of random. Just bear with me. So that's our first one. And now self.pool and so this is just creating the neural net. You can read more into the documentation for PyTorch if you're interested, because this is all just inheriting from the PyTorch neural net module. So now let's move on to our next one. Sorry about this. I got a new keyboard, so Bear with me. Convolution 2 and then dot 2D. So I put my backspace for my left thumb. So now every time I try to backspace something, I do a space by accident. So dot FC1, and these are going to be predictions. Sorry, my bad. This is going to be a lot of this is not going to make sense unless you really read into the documentation. So let's just work through this. And these are just number parameters from, like, again, as I said, like the linear function from the neural net module. Oh, sorry. Yep, it's 1. Thank you for pointing that out. I was gonna check through for typos like after I typed everything. So thanks for bringing that up. So linear 120, 84, self.fc3 equals nn. And that's supposed to say nn.linear above. I'll go back and fix that after. Great, so now we have that. Self.forward, how do we want the convolution, how do we want the neural net to move? Let's say we want it to move this way. So now let's pass in some parameters. X is going to be from our object pool f dot. And this is kind of, remember the activation function I mentioned earlier? Oh my gosh, sorry about this. This is supposed to say a dot. Well, this is kind of like creating the activation function. So self dot conv2, and we're passing in x. Great. X. Now let's view it. We want, these are just parameters. 16 times. And so that. And then we're going to type the same thing, but with 1. So if you want, you can just copy paste that. I mean, FC2. And now we're nearing the end of the neural net self.c3 x. And we want to return x, to return our prediction. So, oops. Great, those are the only 2 functions that we're getting for our neural net. So then net equals net is just, we just call the class and we create another one. Great. So let's run that. Module not found. Oh, because I did not check for typos as I said I would. I don't see any more typos. Great, so let's just run this. See, so net equals net super object. Something must have happened with our, okay, so my bad, this was a typo. I wanted to call the neural net, but I called set for some reason, which is, so cool, no errors now. So let's move on. this, I wanted to show we're just calculating the loss function as part of the math. So let's just click run, and it should have ran. And now let's train the model. So as we train the model, we're going to be like looping through. We're going to loop over the data set. Well, you would do this multiple times in a real life scenario, but in this case, we're just going to do twice because it would require a lot of computational power otherwise. So with that, let's get started for epoch. And that's just machine learning words that they like. So range 2, we're going to loop over this multiple times. So we have a loss function, which is part of the math. Let's say for now it's 0. I'm getting a name error, not sure why. When you run this, right? Did you make sure to run like all the other modules above it? Because you would have to have all of these variables and imported libraries. What's the name error for? And feel free to just like unmute yourself if you want. If you can explain it faster with audio. Name error. Net is not defined. From the SuperNet self line? Net is defined either this was not defined for you or this was not defined for you. Okay, thank you. Name net is not defined. Oh yeah. Okay, so you forgot to import torch NN as NN. Or at least I don't see it in your code right now, but actually that was line 3. Okay, so def init self, good, and then super net self was not. Did you import torch.nn as nn? Okay. I have to say I don't know why you're getting that if everything was exactly this. But how about this? So you ran everything before this, right? And I'm just gonna spend like 1 more minute on this because of time. But you ran every other module or cell, Jupyter Notebook cell before this, right? Because then I'm just gonna copy this and then give it to you. Okay, cool. So can you type Markdown in Discord? Oh, okay. Oh, yes. Is it? Cool. So it's the same as in Slack. So you can just copy this, paste it in. If it doesn't work, feel free to send another message. I'm going to move on to the training part so that we're able to get through this whole thing. It works? Okay, that's good. Glad to know. So yeah, no worries. So for and we're just gonna enumerate our training data. in enumerate. Oh, I forgot to ask. Everyone's good with Python, right? Because this whole thing is in Python. So train loader, 0. And now we want to get the inputs. And I'll put in a comment here. Get the inputs, data, because our data is a list of inputs and labels. Something like that. So here, now we're gonna put that and we'll call that data. Now this is more of the math that you guys can look into after this workshop. So there are things called the parameter gradients. Yeah, it's going to be really complicated to explain without knowledge of the math. So let's just write this code for now. And then at the end of this, I have a link to a lot of really good resources. And then you can look into that more. And also, like after the workshop, feel free to message me if you just want to talk about, anything. So now we're just going to move through the neural net and we're going to optimize the output. So outputs is equal to net because we called our net equals that net that we made earlier. So this is our net and we're going to put the inputs as our parameter. Now our loss, this is a built-in function that helps with calculating loss, which is part of the math. And that backward is also a built-in function. And so that's the training part. And now we're going to print out some of the statistics so that we can see what's actually happening. So loss, we're going to increment it by item, by the loss every single time. So if I is divisible, so we're going to print like every 2000 mini batch. So by that, I mean just every 2000, like the stats because we have more, like thousands of images. So we'll go through every 2000 image. So it's divisible by, and just random number, 1999. We're going to print out. Okay, so this part, this is just so I can format it to print out how I want the data to look. So the 5D part is just like, I want like 5 spaces. And then loss is, we want to print it out as a decimal, 0.3f, and as a float. So that's what we want. And then we're going to do this. And just for clean code purposes, I'm going to start working on the next line. So we want to print out our stats now. So now we're going to enter our stats. Epoch plus 1, I plus 1, and then we want to print out our running loss divided by 2000. And then we want to fix our running loss back to 0 every time this loop happens. So back to 0. And now we're going to, as it's training, we're going to print. So we want to know, just for fun, when it's done training. So finished training, exclamation mark. And now I'm going to check for typos, but actually I don't think there are any typos here. Just want to make sure that the formatting is how I want it to look, but let's just run this now. So this is actually going to take some time because it's going to be training thousands of images and we're just printing out every 2001. So so we're going to keep seeing like a new line every time it gets to the other 2000, the next 2000th image. So you can see the loss here. And every time you train this, actually, it's going to look a bit different. I trained this before. Is the goal to minimize loss? Yeah. We don't want to increase the loss. So this is going to go for a few more lines, and then it's going to be done training. And as I said before, this is every time you run this model, it's going to give you a different one because it's learning from random data every time. So what we want to do next is save this model. We want to save this model in anywhere you want, but I'm just going to save it into here. And I can only run this after this finishes. So this is almost done, just a few more lines to go. Actually, you can see that every time the loss is going down. So to answer your question, Shadow Laro, yeah, so it's minimizing loss. It's like reducing the loss every time because it's getting smarter. And the specific numbers look kind of different every time you train the model, but the trend is that it goes down. I think this might be our second last one. Is this showing me how much I'm using? That's funny. Okay, cool. So it's finished training. Yay. Now we can save our model. I'm just going to run this. And now we're just going to, I'm going to print out, we're going to test it on I don't know, 4 images or something. And then as just a really small example, this is not part of the actual process. I just want to show you guys the images so you can see here. This is a cat, this is a ship, this is another ship, and this is a plane. And now we saved our neural net or our model somewhere. Now we're going to load it back so that we can test it on the entire the rest of our data set. So all keys matched successfully. It just loaded. So the rest of our data set, so our test set, that runs. And this is just gonna print out some of the inputs for this one. But now we're gonna test it on the entire data set. And then actually we're nearing the end of the code. So this is the last time you'll have to type code. Cool. So let's call it, we want to just name some variables and let's call it correct. How many images did our model get correct? And then our total right now is 0 because we haven't gotten through any of the images. So we're going to be using the PyTorch library nograd. So this one. So nograd stands for no gradient. So now we're going to loop through the data in our testing set. So for data in test loader. We want to label the images, or we want to say which ones are data because they were in image label format. So now we just added a variable to it. Now our output, now this kind of looks like our training. We are going to call in the images, and we're going to use an underscore as a variable because we don't really care about this one. So predicted is what our prediction is going to be. PyTorch function called max. It's a built-in function, and we're going to put in the data as parameters. And every time we are going to increment the total size so that we keep track of the size. And then if our prediction is equal to what it actually is, then we're going to increment it. So predicted is equal to labels dot. And we're going to add that up for each item. Now we're going to print out the accuracy. And you can say the accuracy of the network, so of our neural net, on the 10,000 images, 10,000 test images is, and we're just going to format the numbers like this. And we're going to go on work on a new line. So work on a new line just for clean code purposes. And then we're going to calculate the percentage of how accurate it actually was. And I'm just going to add another bracket here. There should have been a bracket here. Sorry. So I'm going to check for typos and also wait so you guys can catch up. Okay, now I'm going to run this. And it's going to give us, oh, outputs is not defined because it was spelled wrong. And then it's going to tell us how accurate this was. So accuracy is 53%, which is, not the best, but we did only train this like twice. And in an ideal world, we would be running this over and over and over and over again with a ton more data. So 53. And then you can run this. This would tell you the accuracy of like every single one of those images that we had. So we had plane images, we had car images, we had bird images, we had deer images, and it just tells you the accuracy of like all of those different categories. So we were the best at recognizing planes, we were second best at cars. Oh, this actually, sorry, we're best at frogs. I thought this was ordered. So we were best at frogs and we were the worst at dogs. So yeah, with that, that's the end of the coding portion. And that was pretty quick. Is it normal for our results? Yeah, it's normal for our results to be different. So when we trained our model, like that would have given you a different, do you see these loss functions? Every time I run these, I get different ones. So you would have different ones. Did you get the same accuracy? I'm interested in that because both times I got 53. Yeah. And the more data you have. Nice. actually we're ahead of schedule because this was going to take us a really long time, but it didn't take us a really long time. I'm glad it worked for everyone. I can open the floor to questions and I'll try my best to answer them. Like, I'm still learning a lot myself right now. AI is a huge, huge field with a ton of knowledge, but if you have any questions, I'll be happy to try to answer them. Oh, sorry. Before that, I want to share something with you. So I created a repo of, so this was the notebook that we used together. It takes forever to load all the time, so just, it's fine. You all have it in your Google Drive. But this is resources, and I can send you guys the link for this. And these are really good resources, and I can walk through them with you because we have, a lot of time left. So the first one here is a Udemy course, and it used to cost a lot of money, but now it's only $17. And it takes you through a ton of the neural net. So we only talked about really simple neural net here. And at the beginning of this, someone asked me like what kind of other machine learning techniques there are. Well, there are actually a ton of different techniques of neural nets. There are convolutional neural nets. There are recurring neural nets. So these are called like CNNs. These are called RNNs. And there are a lot. And this course teaches you like the intuition behind a lot of the concepts. So it will give you a more in-depth understanding of all of these concepts. And yeah, it I'm trying to see how long this is. Oh, 22.5 hours of on-demand video. So if you're interested in taking a course during like summer or something, this is a good one that Stephen recommended. Said it was really good. He went through it himself. So the second one here is Andrew Ng's course. Andrew Ng is basically a celebrity for his deep learning course. A lot of people have taken this and have loved it. And I think the specialization has a ton of courses. So there's a course 1 where you get the basics, course 2 where you go more into deep neural networks like tuning and everything, optimizing. 3, more projects, and then 4, you talk more in depth about the specific type of neural net, and then, yeah. Oh, Steven has not finished it yet. He's still taking it now. Yeah. I mean, last time we spoke, he mentioned that it's really helpful. So it would be something you guys could look into. And then sequence models, like it brings you more and more complicated concepts, but I've heard from a lot of people, and we can see here from the 5-digit ratings that these courses are really awesome. Of course, that's a lot of commitment, right? You don't want to start a course and then not finish it, especially if you don't have time. So I also chose some good YouTube channels for you guys. You can watch it at like lunch or dinner or something, or just 20-minute videos on like what is machine learning, how does that work, working with different types of libraries, pandas, sk, scikit-learn, and then like a lot of concepts. Not specifically deep learning, but a lot of different types of machine learning. And they teach you version control too. But this is really good. He's really good at explaining things. So There's something called, if you want to work more specifically in deep learning, there's a deep learning TV. It's what's called deep learning TV YouTube channel. Yeah. And they're just like 5-minute videos on deep learning, you know, Boltzmann machines, which is like another, it's more another concept. What's a neural net? The reasons to go deep, like what's a deep learning library? This PyTorch, this is TensorFlow, like I mentioned before. And it has really good animations. So, oh, these are deep learning libraries and these are concepts. It has really good animations. So I would recommend that one. And if you're less into, video courses and videos, I also found some Medium articles for you. I enjoy reading Medium articles myself. So this is just like an intro. It's just a 7-minute read. If you like diagrams you can stare at for longer, and you can see the difference between, AI, ML, and deep learning. And it talks a lot about like, just different applications of it and implementations, what's a neural net, right? And then it goes more into the math here. And yeah, these are like the weighted functions and then the biases and everything. And this is all the math involved. And this is actually, I think this is chapter 1, right? So I think there's actually, more chapters in here that I didn't really read into, but there are a lot of good articles here just talking more about AI, deep learning, and data science that will get you more familiarized with the environment and the language that people use in this field. A lot of the research scientists I work with at Element AI really like reading articles and papers. Papers are a bit boring for me, I find, but articles like this really keep you in the loop about what's going on, right? So natural language processing is super cool. And yeah, these articles are really awesome. You learn more about emerging tech. And then I found one kind of like a pot that gives you more gold, or like the money tree that keeps growing money. This is 100 articles that will make you an AI pro. So this is a technical guide, machine learning for humans, understanding natural language processing, chatbot stuff, Python and Docker. We use Python and Docker as our main, not our main tech stack, but for a lot of, yeah, I think I can say our main tech stack. It's our most used two things, our Element AI. So if like working for AI startups is something you're interested in, Python, Python and Docker are really, really, really important. So that designing AR is so cool. Cheat sheets. Anyways, this is really long. There's 100 of them, but transfer learning is also another type of learning, right? We have reinforcement learning, transfer learning, deep learning. Yes, there's going to be a Docker workshop on week 4, so make sure to attend that. And then this learning AI when you suck at math, that's basically me. So yeah, this is, yeah, there's a lot here. Wait, what? It ends at 25? Not sure how that's, oh, it's because it's part 1. Yeah, so I guess there's a part two if we stalk this guy. Anyways, I didn't want to give you like a whole super long list of resources because I find that whenever I'm given a super long list of resources, I find it very intimidating to go through them all. So I think this is a good, short, sweet list of resources that you guys can dive into. And if you find any better resources, I don't know, feel free to send them in this Discord group. I'm sure a lot of people would appreciate it. And there are 15 minutes left. I guess I can, yeah, nice. Oh yeah, computer file is really good. Explaining like deep learning and AI things, but also like other computer science concepts if you guys are interested in that. Yeah, thanks for sharing. So I guess I can open the floor to any questions if you're interested in like my internship, how to get more involved with AI at school, kind of stuff. Just yeah, feel free to ask any questions. Stick around for like the next 15 minutes.